Welcome back to Algebra. We are here to talk about Lesson 11-8. We're going to talk more about rational expressions, but today we're going to bring in one last step about this rational stuff that we've been doing and add in the equations, which means that we're going to have problems that have an equal sign in them. So the first thing that we're going to do is a sample problem on page 720. Your sample problem looks like this. You have a 3 over x plus 5 equals 2 over x. Okay, once we have that, we have to figure out how to get x by itself. Anytime we have an equation and a variable, we're always going to want to get that variable by itself. The nice thing about this is once you have two rational expressions, one on each side of the equal sign, all you have to do is cross multiply across the equal sign. That means I'm going to find that equal sign and I'm going to make an x on it. And this x is going to be multiplied up to that side, which gives me a 3x. And this denominator is going to be multiplied up to that side, which is going to give me a 2 times x plus 5. Now we know exactly what to do. We can say 3x equals, what do you get when I multiply that? 2x plus 10. Subtract the 2x, x equals 10. Ta-da, that was not hard at all. So we're really just using all of the algebra that we've been learning all year long to put it together and solve for x yet again. Okay, another example on the bottom of page 720. I want you to pause the video and do this one, which is 13 over 10 equals 2f plus 0.2 or 0.2, I'll write that 0 in there, divided by 7. Okay, pause the video and you do this one on your own. Okay, here we are ready to go. Since we have two fractions, two rational expressions, all we need to do is cross multiply across the equal sign. So this denominator is going to be multiplied by the other numerator, 13 times 7. And this denominator is going to be multiplied by that numerator. So that's going to be 10 times 2f plus 0.2. What is 13 times 7? Pull out your calculator, figure out what 13 times 7 is, and you find out that it's 91. And 10 times 2f, well, 10 times 2 is, I hope you said 20, 20f. And 10 times 0.2 is just a 2. Multiplying by tens is so easy. Okay, now we can just subtract off the 2. We get 89 equals 20f. And now we can divide by the 20. So that's f is going to be equal to 89 over 20, which is 4 and 9/20. Or if you would rather have a decimal, it is 4.45. Did that in my head, so double check me, but I think that's right. Okay. And the way I know that is I know that there are 20 nickels in a dollar, so every nickel is worth 5 cents. 9 times 5 cents is 45. Weird things teachers do in math. Okay. Let's do another example on the top of the next page. This time the starting problem that they give us is 4y plus 5y over y plus 1 equals 5. Okay, how do we do this one? Now we don't have just two rational expressions. How are we going to do this? Well, the best thing that we can do is maybe get the common denominator all the way across for all three of these things. So I know that if I wanted a common denominator, the denominator under the 5 is just a 1. So that means in order to get my common denominator, it's going to be a y times a y plus 1 times 1, right? Well, I can kind of ignore that 1, but that means on this one, I'm going to be multiplying by a y plus 1 over a y plus 1 in order to get that denominator included. On this one, I need to multiply by y over y. Honestly, that doesn't look too hard. And this one, since I don't have either of these two things, I'm going to have to multiply by y times y plus 1 over y times y plus 1. All we're doing is getting a common denominator, okay? It's not that tricky. So that means here I have 4y plus 4. Here I have a plus 5y squared. And here I have equals 5y, and I'm going to just leave that as 5y times y plus 1 right now. Okay. 5y, oh, and I forgot, I didn't write the denominator in here. So on this side, I'm going to have a denominator of y times y plus 1. And on this side, I'm going to have a denominator of y times y plus 1. Now think about what happens here. Check this out because this is super cool. As soon as I do this, I've got the same denominator on both sides, right? The same denominator on both sides. So that means that I can multiply y times y plus 1 on this side. And if I multiply that on the left, I've got to multiply that on the right. And this is going to cancel with that. And this is going to cancel with that. And I don't have any denominator anymore. So that's pretty cool. As soon as I get a common denominator on both sides of the equal sign, they just cancel off and I can ignore them. That means now I have a 5y squared plus 4y plus 4. I just rewrote this one with the 5y squared first. And here I'm going to multiply this to be 5y squared plus 5y. Just distributed that through. Didn't have to FOIL because there's not a plus sign on this one. So I've got a 5y squared here and a 5y squared there. I can subtract that off, right? And that gives me 4y plus 4 equals 5y. I can subtract 4y, and I have 4 equals y. Ta-da! Little bit trickier because we had to get that common denominator to start with, but I want you to do 2a on page 721, 2a, and that will let us know what's going on. So you pause the video and do 2a. I want to write the problem down. It's 2b minus 5 over b minus 2 equals 3 over b plus 2. Again, pause the video and try to do it. Your first step is going to be getting a common denominator. Go. Do it. Okay, welcome back. I know you've made a really good effort. Let's do the first step to see what we need to do. We need to get a common denominator, so that means we're going to have a common denominator of a b minus 2. This one we're going to multiply by b plus 2 over b plus 2 so that we have our common denominator of b plus 2 times b minus 2. This one, we didn't leave enough room. Oh, Miss Holly, what are you doing? So we're going to be multiplying the top times a b plus 2 times a b minus 2. And on the bottom, it's going to be a b plus 2 times a b minus 2. And here we're going to be multiplying by b minus 2 over b minus 2. Okay. Now what? Don't forget that you're going to have to multiply this entire thing here. So we're going to use what property to multiply here? You can use the distributive property, but we usually call it FOIL. So here we have, let's see, b times 2b is 2b squared. The outer will be a negative 5b plus 4b minus 10. Okay. Minus 2 times, what is it? b plus 2 times b minus 2? Difference of two squares, so that should be an easy one to multiply. And then we have 3b minus 6. And again, we're going to have the same denominator on the left-hand side of the equation as we do on the right, so that's just going to cancel out and we don't have to write it anymore, which is nice. Let's see, what can I simplify here? I've got 2b squared minus b minus 10. Here I'm going to have a minus 2b squared plus 8 equals 3b plus 6. You all still with me? 2b squared minus 2b squared cancels. Minus b minus 2 equals 3b plus 6. Okay. Oops. Made a mistake there. If I bring this negative b over, it becomes a positive. So we're going to have a 4b. Bring this 6 over to the other side, it becomes negative. So that's going to be a negative 8. Divide both sides by 4, and b is equal to negative 2. Okay, so let's try something different. If you did not get all of this work done on your own when you pause the video, what I want you to do is turn your paper over and write down the starting problem again. And I want you to go as far as you can on your own, and then rewind the video and watch it again so you can see which steps were you making your mistake. And go as far as you can with the video to match up your own work until you find your next mistake, and then pause the video or watch through the video. And if you need to, turn that page over, start it over again fresh, but just keep going over and over until you can do this entire problem on your own without the video behind you. Even though it might seem like you're memorizing the steps from the video, I still want you to go through that process of figuring out how to do each one of these steps on your own. And memorizing the video isn't necessarily a bad thing, but then you can try to do another problem that's much like that. But this is really the hardest step that we're going to be talking about. This is, pretty much the last chapter, the last lesson that we're really going to be covering fully. Got a few things in chapter 12 I want to talk to you about, but this is it, and you guys have worked so hard. I'm so proud of you. One last sample problem, because it's a really good problem. It brings a lot of things into focus from what we've been doing all through chapter 11. This is example 3 on the top of page, on the top of page 722. We have 2n over n minus 5 plus 4n minus 30 divided by n minus 5 equals 5. Same idea. We are going to have to get a common denominator so that we can get rid of the denominators and then solve for n. So here we've got an n minus 5 in our denominator. Same thing. That's easy. What's our denominator here? 1. We usually don't write it, but I can put it there just to show you. We want to get a denominator of n minus 5 so it matches the rest of the denominators. So we're going to multiply n minus 5 over n minus 5. Okay. This becomes 2n plus 4n minus 30 equals 5n minus 5. Again, since I have the same denominator all the way through, I don't need to write it anymore. This becomes 6n minus 30 equals 5n minus 5. Subtract a 5n gives me n minus 30 equals negative 5. Add a positive 30 and we get n equals 25. Something didn't, oh, you know what? I made a mistake. Look back up here. 5 times n minus 5 is 5n minus 25. 25, and then that becomes negative 25 plus 30 is a positive 5. So our answer is n equals 5. Seems simple enough. But let's go back up to this top part. What happens when I put in a 5 for our n? What happens to that denominator? 5 minus 5 is 0. Is 0 ever allowed in the denominator? No, we can't do that. No zeros in the denominator. So our only solution for this problem creates a denominator that's 0. And that is, what's it called? An excluded value. So from the very, very first step, we knew that n cannot be 5. And then we solve the problem and we find that n is indeed 5. So what does that mean? That means that there is no solution. So remember, all through this module, or all through this chapter, I've been talking about how it's good to keep an idea of those excluded values all the way through. So now we know that we have an excluded value at n equals 5. The only solution that we could possibly have is when n equals 5. So there's no solution or null set. Accidentally did that. Still worked. Okay. So go through your homework, see what you can find out, see what you can do on your own. Lots of good stuff that we're learning here. You know the answers are in the back of the book for the odd problems, so you can check them. Otherwise, we will just talk about them in class on Tuesday. and answer any questions you might have there. Enjoy your homework. I will see you Tuesday. Have a good week.